good morning, everyone. My name is Donald Robertson, as I said. I'm going to be teaching Calc 2, and I think I'll tell you a little bit about myself. I'm from Scotland, and I do not have an accent. I've always told my students that. This is going to be, I've finished 41 years of teaching. This is me starting my 42nd year of teaching. I started in August of 1980. That's when I started getting paid to teach. Doesn't mean I'm very good at it, but at least I'm finding lots of ways not to do it. So that's always something. Most people get used to the way I speak. It isn't really an issue for most people. Occasionally, I'm told by some that when they do their homework, they hear a little Scottish voice. So you might experience that. So I'll just give you a big picture. What is Calc 2? I'll tell you what Calc 1 is first. Very, very simplistically. Calc 1 was, it started off by solving a problem called the tangent line problem, which was basically, how do you find the slope of a tangent line to a continuous curve at any given point? And that basically was the beginning of what we call differentiation. So Calc 1 was, algebraically, how do you differentiate things? So that's product rules and quotient rules and chain rules and all the other rules you've discovered. So how do you differentiate? And then the second part of Calc 1 was, okay, now you know how to differentiate, do stuff with it. So you could use it to find slopes of tangent lines, but couldn't you also use it to find velocity of moving objects and to solve optimization questions like, what's the best size to make a box so it has the smallest surface area, whatever it might be. And that's what Calc 1 was. So what's Calc 2 going to be like? Well, it's going to start with a problem. And the problem is called the area under a curve. And they solved it. And what that ended up doing was creating what is called integration. And Calc 2 is going to be, how do you integrate things, right? So think of integration as a process that you do to functions, just like differentiation is a process, right? You do to functions. We're going to do integration, whatever that might become, you don't know yet, but you'll find out. So we'll spend a lot of time finding out how to integrate things, integrate functions. And then once we've figured that out, we'll then say, okay, what can you do with these integrals? And we'll show you that you can use them to find areas under curves. You can do velocity acceleration type questions. You can find arc lengths, surface areas, volumes, the work done. Oh God, tons of things you can do with these. And that's going to be Calc 2. So that's what you're going to learn. How to do this process called integration, and then how to use it to do cool stuff. So if any of you intend to become scientists or engineers, I can guarantee you are going to integrate things. Just like I can guarantee you're going to differentiate things, and some of you might already have done so. So this is going to be a branch of math that you're going to end up using. So what's the first part of today is going to be is the syllabus, as it always is. I'm going to try and make that as quick as possible because I'm working the assumption that you're all intelligent and that you can read, and so that you can always go and read a lot of the stuff I'm going to do, so you don't need to frantically write it down because it's basically in Canvas. But let me nip over there now if I can. This is always fun. Oops, somebody just turned up. Are you all looking at Math 152? Canvas site.
Yeah, I can see the canvas site on your screen.
Okay, good. Right. Something weird has happened. Normally I get to see myself and I get to see you. So if you nod your heads, I can see it. But for some time, for some reason, it's decided not to show me that. So this is essentially your Canvas site. It has a number of features, a number of things. Just closing these up a little bit. There we go. There's your three main modules. Over here on the left, you've got your syllabus. Fingers crossed that are you somebody just say, yeah, you're looking at the syllabus?
Yeah.
Yeah.
Okay, we're good. Right. So there's me, there's my email. First thing I would like to tell you is we're going to be working on a platform called WebAssign. That's where all your class assignments are. That's your homework. That's all the good stuff is. And that's where your ebook is. And a lot of the time people get stuck and they want help. There's a feature in WebAssign called something like Ask Your Professor. And sometimes you won't be able to do the homework on the allotted time and you need an extension. And WebAssign has this other place called Ask for an Extension or something to that. And what I'm asking you to do is do not use those features because I don't get them directly. They don't get sent to my email and then I can read them. They just, I don't know, they float out there in the ether like little lost children. So if you need extra help or you want to get an extension or whatever it is, you do it by using my email address, drobertson@olympic.edu or Canvas, which Canvas is fine because Canvas is linked to my email address and I can see everything. So remember to do that. If you don't, you're going to think I'm ignoring you. You're going to say, I'm stuck in question 5. It's driving me crazy. I really, really need help. And 5 days will go by and you won't get an answer and you'll think, oh, he's just not going to talk to me. No, you did it on WebAssign instead of emailing me. So keep that in mind. Right, we have an officer. This just happens to be a Zoom one and it's a drop-in. There's the link. You know how to use Zoom at 10 o'clock. That's when it's going to be every day. That might not suit you. That could be your English class or something. So what you do instead is you shoot me an email saying I'd like to talk to you about whatever, and we'll figure out a time where I'm free and you're free. My schedule is very tight, so I can guarantee that I'll see you, but it will either have to be for you lot probably just before class, or it would have to be either at 1 or 3, depending on which day of the week. It would have to be after 1 or after 3. So hopefully that works. You're in this class because you've got the prerequisite, but if you don't, eventually I get told and I have to drop you. I'm allowed to change things, which I probably will do, but hopefully not by much. Mostly what that means is I may change the due dates for some homework. It's difficult to judge. Every class is different. I've put down a whole schedule, as you'll see later, of what we'll be doing in any given week. But sometimes we do things a little bit slower because we need to, or a little bit quicker because things click. And so I adjust things if that happens. Right, what do you need? Well, you need a reliable internet. You need a computer. Really, you can't do this class on a tiny little screen called a cell phone. I think the webcam's fine if you want to use it for just that, but you really do need a computer just to see your homework, for instance, in a size that is actually readable. Here's features, resources, I should say, that you can click on and you can see all the cool stuff. But OC will give you loaners of computers, of webcams, of earphones, of anything. Financially, if you've got a problem, as you are students, you probably do, and the Sing office is there, students in need group, and they have some money that they can use. It is limited, but they do have money and they can use it to, for instance, buy the license, I guess you'd call it, the code to do WebAssign. And that's where this is. Now, I think the last time I looked, there was 10 people already in this class who'd registered. So that means there's another 11 of you still to come, or whatever the right number is. I haven't looked at the new class list. Read these instructions here. In particular, if you click on that, which I'm not going to, but that one just basically gives you a blow-by-blow way to join WebAssign. So if you've never done WebAssign before, it's really just an online platform where you get your homework questions and you do them in paper and you get the answer 42 and you type it in. Or your answer is a graph and they give you 4 choices and you pick the graph that's the right answer. So it's really just, that's its main usage. It's a nice way. It's kind of cool because it has a lot of features, like it'll give you other examples sometimes of questions like that one, so you can get an idea because they show you the solution to it. And sometimes they have little videos you can watch. It's also where you can get your ebook, so you can actually get a textbook that's online, so you don't need to buy a physical one unless you want one. I'm assuming everybody knows how to do Zoom, but there is a Zoom thing. Here is a list of all the cool dates. If you look, you can see there's 3 tests and a final. There's some holidays as well. And here is essentially what we'll be doing over the next 11 weeks. So we're going to, hopefully you'll all have done it, but that's just getting started in WebAssign. It's very quick. The first real work we're going to do is solving the area problem numerically. 7.7 is just the same as 5.1. It's just a little bit more complicated techniques for doing it. But 5.1 and 7.7 are, for the most part, numerical approximations to the what's called the area under a curve. And then 5.2, we solve the problem algebraically, essentially, and we give you a technique, a shortcut technique for getting it, which is much better than Calc 1. If you remember Calc 1, we spent forever and a day doing limits and the algebraic techniques for finding limits. And it was, God, I think it was took to what, the second week before you actually got to see the shortcut. Can you see that you'll be seeing the shortcut by Friday? So it's going to be a lot quicker, right? You'll get right into the algebra. Any questions so far?
The assignment schedule, the days column, it says, you know, Monday through Friday. That's the content, right? And then the third column is when the homework itself is actually due. Yeah, so this is week 1. This is the days that week 1 are for, right? That's from then to then. That's what week 1 is. And homework's always due at midnight on a Sunday. So it's not like you have to have it finished by Friday. You have your weekend. A lot of you might have jobs or other commitments. So midnight on Monday is when the thing is due. Any other questions? Okay, right. Well, we do 3 weeks worth of work and then we do a test. And I'll talk about the test closer to the time, but basically the test is on stuff that you've done from year to year. And then we do another 3 weeks called 4, 5, and 6, and there's a test. And then we do 3 more weeks, and then there's a test. And then week 10/11 is kind of merged into 2, and the reason they're merged into 2 is because Thanksgiving is there. So one of the weeks is virtually annihilated because one of the days is a test. 2 of the other days are a holiday, so it's not really worth having a 2-day week. So I just bashed them all together. And that's the last thing we'll be doing, which is differential equations, or at least the intro. And Monday the 6th is a class day, and that's a review for the final. And then there's your final. And you notice your final is going to be 3 hours, but all your tests, although I haven't said it, are just during class time.
They won't be, they'll be usual, 50 minutes, an hour. Okay, here's all the learning objectives. You can read them. You can find out all the cool stuff. Don't cheat. If you have some accommodations, tell me about them. So let's look at points make prizes. How do you get your points in this class? Well, they're going to be a 20% on participation. That means coming to class. So every single one of you right now has already got some points for turning up. And they're 20% every day gets added, and then it's converted. So if you come here every single day, you're going to get 20%. So your grade is 20% plus. Homework, 30%. Those tests we talked about, 20. And then your finals, the other 30. And hopefully this is accurate. This is the Zoom link that you'll be using to come to class. Homework assignments, what I'll talk about in a little minute, is going to be done in WebAssign. And there's my little spiel again. Email me, don't use WebAssign. 3 tests. Best 2 get counted. So you can have 1 stinker and it won't affect your grade. Final exam and some extra credit. And the extra credit for you lot is going to be connected to your homework assignments. Every homework assignment that you complete inside the time, in other words, you don't ask for an extension, you'll get 0.5% extra credit. And so you could get 5% on that. So if you do all your homework inside the right times, so that's a plus. Now, what about those people who ask for extra time? They will get extra time. What they won't get is extra credit, of course. So it's not that they get a ding to their grade. Not doing your homework in time stops you getting bonus points, right? Extra grade. And I would think most people want to get those 0.5%. But there is a limit to an extension. All I will give you for an extension is an extra week. I won't say, okay, well, just don't do the homework. Don't worry about it. As long as it's finished by week 11, I'm fine. No, I won't be fine. At the end of your extension, if you haven't done it, then you ain't doing it. It'll just get locked out and that homework will disappear and you won't get any, well, you'll only get the points for what you've done. And then your grade and letter grades and cool people to talk to. General advice. Come to class, pay attention, seek help as soon as you can. We have lots of tutoring services. They're all free. They have an online tutoring service, a lot of good stuff there. Try not to do your homework at 9 p.m. on a Sunday. Not a good idea. You don't learn as much. The best way to learn, in my opinion, is do the homework as soon as we've done the topic. That way you'll know whether you understand it or not. That's one of the things homework allows you to do. Yeah, it makes sense in class, but when I actually get to do a question on my own, maybe I don't understand it as well as I thought. Second thing for homework, a big thing, is it's practice, you know? You don't get good at playing violin by listening to other people. You get good at playing a violin by doing it yourself. And there's all the things that we try not to do or give you accommodations for, if you are. And my favorite saying, sit back, take a deep breath and say, I can do this. Okay, there's a lot of information there, but hopefully you know you can go back here and read it. But is there anything any questions? Okay. Assuming that's a good sign. Let's zoom over. Can you see WebAssign now?
Yeah, with the current assignments.
Yes. Okay, so let me make it look a bit more like you should see it. Right, if you've done WebAssign, especially if you've got me, you've done WebAssign, this is no biggie. Can you see that essentially what you have is our class? And if we scroll further enough, there's your ebook. So if you click on that, you can actually, you know, just like a textbook, but it's in some kind of like PDF version. There's your get it started. I don't know if this is going to work. I keep worrying when I hit buttons on Zoom that it's going to handle it. But here are your homework assignments. Do you notice that you have got up to indefinite integrals? That's week 1 from here to here. So there are 4 of them. But I think getting started one takes less than half an hour. So you should be able to zoom through that without any hassle. And these are going to be more time consuming. And then here is week 2's. So if you feel like working ahead, you can actually do more than is currently required. Right, so let's pick this fella and kind of show you how WebAssign works. Yeah, okay. You're looking at question 1 and a function and a nice little curve on it?
Yeah.
Right. So don't need to worry about what the question is because we're going to cover that. But essentially, you go here and you answer it and it says, what's the estimate for the area under this curve? And the lower estimate, you think it's 12. The upper estimate, you think it's 13.7. And if you have done the working correctly and you hit submit answer, it will have a nice green check mark because you did it right. But you might want to read about it and you might want to watch a video about it. So you could certainly do those, especially if you're saying, nah, I've looked at the Zoom thing and I can't remember what he said and whatever. So you can read about the question, you can watch it. You don't just have one shot at it. You get 5 shots. So if you don't get the right answer the first time, you get another 4 shots to get the right answer, and then that's it. Things to watch out for. Sometimes the obvious will kill you. See how here it says 1 decimal place? Do you know if you put the answer to 2 decimal places, it will probably tell you you're wrong? It seems a bit cruel, but you got to remember this isn't a person, it's software. So they have no compassion. If they want 3 decimal places, they don't want 2 and they don't want 4. So you have to follow that. If they want a fraction, give it to them as a fraction. If they say they want a percentage, give them as whatever it is as a percentage. Okay, you'll be pretty comfortable about the process. It's just like doing a normal homework question. Most of what you're going to do is in a bit of paper that nobody sees. All that eventually gets shown is the final result. Any questions about WebAssign then?
For the 5 shots to get it right, is after that, does that question gray out forever or does it change variables?
No, it's dead.
Okay.
So, it'll happen sometimes that you keep doing it and it doesn't work, and then you find out, oh, darn it, I should have read that extra bit at the start or whatever. We all learn by our mistakes. Every homework is worth a nominal 100% or 100 points. And so basically your homework is just everything added up. It doesn't matter if it took you 3 shots or 5 shots or you got it on the first shot. Once it's correct, it's considered correct. It's not like a graded thing. Well, you get 5 points if you get it the first time, but you only get 1 point if you get it on the 5th shot. It's nothing like that. It's right or it's wrong. If you get it, you get the points, no matter how many shots. So hopefully that'll make it a little bit easier for you. Okay, I think WebAssign, if you've done it before, is pretty easy, pretty straightforward. If you haven't, I think you'll probably get into the swing of it relatively quickly. So I am now going to stop that sharing, and nice to see you all back again.
Is it going to be? Is it going to be common like the next week's worth of content will be visible in WebAssign each week?
Yeah.
We can like work 1 week ahead each week.
If you want to, yes.
Okay.
You don't need to. I'm not saying you should. Just some people, it might work better for them. I have decided to jump back to our Canvas site because, being forgetful, I forgot to tell you some other cool stuff that's in Canvas. Canvas is a resource for you. And basically, I put stuff that I think will be helpful. So if I click on the first module, you can read about welcome to the class, how to do set up WebAssign, and some help with Zoom. Here is the link to our Zoom meeting. And it's the same information, the same link for about 2 months. So you'll use the link you used today in the coming weeks. If I click on this one, let's do a student view. Right, if I click on this one, what is stored in here? Well, here, Zoom lectures, the link. And here, if you click on this fella, you see a whole load of blanks. But every single Zoom, including this one, gets stored here. So if you miss Tuesday, you will come here, and that second link there will be our video. And over here, I'll say how long it is and some minor description of it. So I think that's useful because sometimes when we do, say, a question in class, I write down some stuff and you might have misheard or forgot what I wrote. You can always go back and have another look at it. I'm going to make a big assumption here, and that assumption is that you do not mind me copying these Zoom lessons and putting them online. These are isolated. What does that mean? It means you're the only people who can see these videos. So it's not like it's out in the, they're stored indirectly in YouTube, but nobody in YouTube can see them because it's private. So if you're worried about that, maybe that'll relieve your fears. So you go here and you can get it. So there's one of the resources. If I click on the college resource one, here are, you wanted to find out about tuning, there you go. All the usual stuff. Computer lab, Canvas tutorials, things that the college are good at. And here is some other videos that I have made. So for instance, this thing here will make no sense to you yet, but it better in about a week from now. Come on. Maybe I shouldn't have hit that button. Oh, there we go. And it's basically what are called standard integrals. I won't scare you too much. When you look at them at first sight, you go, God, no. They're not as bad as they look. So that's one resource. If I click on this, chapter 5, I click on that, for instance. And that's the topic we're going to do right now. If I click on this, here are some videos. And they're made by myself, other professors at the college, or just ones that I found that I liked the way they did things. And the reason why there's duplication is one person describing how to do something and then another person describing how to do something, one makes sense to you and the other doesn't. So it's always good to have multiple ways to look at or to see these things. So that's what they're there for. This one here at the end is one, for instance, I've done, and that's basically a little bit on the calculator, the TI-84, just to save you some time on doing what's called sigma calculations. No, it's not a biggie. A lot of people don't use it, but some of you who are really into using calculators might do it to simplify the number crunching that you have to do. So that's kind of, oops, go away. Right, there's a guy there called eTutoring. You have already paid for it. It's basically like online tutoring. You can find help on any of the topics you want. I'll let you click on that and have fun figuring out what you can do and what kind of help you get. Now you can see here that I've got all sorts of other stuff. Let's pick chapter 6 now. If I scroll down to the bottom, oh, that should be a little bit nicer. I'll try and make sure. There. I'll fix that. Evidently, things are not quite. Oh, yeah. Sorry about that. Well, there we go. Here are some notes that I've put together. I'll make that. That sounds like a Canvas issue I've got. But basically, these are my notes on that particular topic. I wonder if this one's is a little bit cleaner. They'll probably all be the same because it was, yeah, they are the same, right? Okay. Well, let's note to self, get that fixed. And here are PowerPoints. I strongly suspect I've got the same thing. It's not a biggie. It looks like Canvas has shrunk some of my windows down. I just need to go in and tell them to go to default. So, as you can see, there's lots of stuff to help you. So, that's it. Any questions before we actually get started and start doing the cool math stuff?
Are the exams gonna also be through WebAssign, or are those done through Canvas?
Good question. They are not going to be done through WebAssign. They are going to be a PDF that you will get in Canvas, just like you would turn up to class and I hand you a piece of paper with the test question on it. I'm going to hand you a PDF virtually, and you will be doing those questions on paper. And then you will be using, I've got a number of programs, but the one I'm kind of leaning towards now is called Microsoft Lens. I don't know if you've used it, but if you've got other ways, that's fine. Essentially what you do is you take a picture of your exam, right, your test, and you send it to me as a PDF. And I'll show you how to do that closer to the time. But if you've ever done any of my tests, it's the same thing, right? It's just that the questions will not be on WebAssign, although I'll use WebAssign to choose the questions that I pick. So they won't be that different from what you see in WebAssign, right? Just a slightly different approach. Any other questions? Okay, I'm dying to get to this bit. So work, yay. Let's look at the problem that generated calculus 2. It's called the area under the curve problem. You remember the tangent line problem for Calc 1? what's the slope of a tangent line to a curve at any given point? And that eventually became calculus and differentiation. Calculus 1. This is going to become calculus 2. So let me show you a simple version of the problem. One of the things that mathematicians, scientists and general engineers, is that they get problems and then they try and figure out how to solve them. So here's a problem. I want you to imagine that I have a piece of a curve. Starts there, finishes there. And we'll call this curve y equals f of x. And let's say that it starts at x equals 1. And there's 2, there's 3, there's 4, there's 5. And it finishes here. When I want to know the area under a curve, I want to know this shaded area. This is what we mean by the area under, right below a curve. So the x-axis is like the 4, and this curve is above it, and we would like to know the area under the curve. And we'd like to be able to do it for any nice continuous curve. If this doesn't look exactly like the one above, well, you pretend it does. There. So there's me duplicating the thing. So we'll start off by estimating. How could you, what kind of method might you use to estimate the area under a curve? Any ideas?
You could take the average sum, like the median between the 2 points, in order to pretend it's like a square.
Or a rectangle, yeah.
Yeah.
That's a very common technique. So what they did, if I'm picking up what you're thinking about, is that they broke this shape into what they call strips. In this case, I think it's pretty natural. There's 1, 2, 3, 4, 5 of them. But I could break it up into 2 strips or 22 strips, but whatever. Break it into a number of strips. In this case, there's 1, 2, 3, 4, 5 strips, and you will see that we simplify that by saying n equals 5 strips. Of course, if I wanted to do 10 strips, wouldn't I just put an extra line in the middle of all of these, and I'd get 10 of these little strips. And then, if I picked you up right, you said we could use the middle, which would be somewhere here, or I could have, say, used the left or the right if I wanted to. And I'm going to pick, say, this first strip, the one from 1 to 2. I'm going to pick the right-hand side. And if I pick the right-hand side, I get a little rectangle. And couldn't I find the height of that rectangle? Because it's just the value of the function when x is 2. And don't I already know the width of this rectangle? In this case, isn't it just 1? The width of these strips is called delta x. And the height of the function, and well, I guess I should put numbers on this so we can maybe play about with it. So this is 1, 2, 3, 4, 5, 6. So wouldn't this rectangle be 1 wide and 6 tall? So the area of this piece would be 6. Right, here's my second strip.
And I'm going to be consistent here. So in this first strip, I chose the right-hand side to get the height of the rectangle. So in this second strip, I'm also going to choose this side, right? Not that one, but this side. And here is my second strip. And it's 1 unit wide, and it's about 5.8. So 1 times 5.8, that's this fella. Now, for this one, I would use the third strip. I would use the right-hand side again. And that's about, I don't know, 4.5, say. Then if I take my fifth strip, it's about here. And this one is 1 unit by about 5.2, I'm saying. And then in the last strip, I would be using the right-hand side. And this would be 1 unit by 7, 8, 9. And so that would be 9. We would call this an estimate, right? Because it's obviously not the perfect answer. And you'd get it by just adding the area of each strip together. 11.8, 15.8, 16.3, 21.3, 21.5, and 30.5, whatever the units are, square units. Does that seem like a practical way of solving the problem of finding the area under a curve? That you break it into a number of strips, in this case 5, and then for each one of those strips, you make a rectangle that is roughly a fit. Would you agree that this rectangle is actually a little bit bigger than the real area would be? This one, on the other hand, isn't that a little bit smaller than the area? This one is a little bit smaller. This one's a little bit bigger. This is probably a lot bigger than it should be, but whatever. Isn't there some kind of balance, not a perfect balance, where the ones that are overestimates, bigger than the true answer, get compensated at least a little bit by some that are underestimates? That seemed like at least a good starting point to estimate the area under a curve. Any comments about that? Okay. I'd like a better answer, a more accurate answer, using this technique. How could I do that?
Using the center instead of the right-hand side of the bacon strips.
Okay, so I could use what's called the midpoint, and that would give us the height of each rectangle. That would certainly be typically a more accurate answer. Totally cool with that. There's another way, still keeping the right-hand side one, although I agree with you, the middle one's better, but I could keep the right-hand side one and still get a better answer. Nothing too weird. What would be the simplest way? It'll involve a lot more work, but it'll at least be a simple way.
More strips.
More strips. Just do 500 strips. God forbid you had to do it by hand, but can you imagine that you could do as many strips as you want? As long as I give you a formula for this fella, right? Suppose I tell you that this guy is the sine of x plus pi over x plus 1 or something, right? Whatever it is. As long as I tell you what the function is, right? Can't you find the value at each one of these endpoints, as we call them? And then add them all up, make sure it's width times height. And you could do that for 50 strips or 5,000 strips. Now, what you do in reality, if you want to use this technique, is you go to your computer and you write a very small program and you say, add up 1,000,000 strips. Now, can you imagine if I did this with 1,000,000 strips? Wouldn't the answer be darn close to perfect?
seem reasonable that if you split it into enough pieces, each time you did it with more and more strips, shouldn't the answer get more and more accurate, right? Less bits that don't fit quite as well. So some terminology. This technique where I put them into strips and I use the right-hand side, that guy is called R5. R, you're using the right hand of each strip, you're using the right-hand side to get the height. 5, because you're doing 5 strips. There's another guy called M5, and there's a third one called L5. Right, things are going to get really messy because I don't have time or probably patience to draw another one of these curves and do it again. So I want you to imagine all these red guys are missing. If I wanted to do an L5, take my first strip. Do you see on my first strip, I have a left side and a right side. L5 would say use the left-hand side. Do you see this green guy here? That would be the one you'd get here. For the second strip, it would be this one up here. For the third strip, it would be this one here. For the fourth strip, it would be down here. And for the fifth strip, it would be here. Now, do you see that the answer that I would get would be made up of 5 rectangles, but wouldn't their heights be different from the red ones that we just did? But wouldn't that also, if you did enough strips, wouldn't that be a pretty decent estimate? And the mid one, not even got a chance at doing that one. So I'm going to pretend that I've got one of these strips already. Imagine this was the guy, and here would be the start number, and here would be the finish number. Let's say a blown up version of here. Well, it's pointing the wrong way, but whatever. Couldn't you pick the middle and use that guy to be the height of your rectangle? And that guy would be called M5. And that's pretty much, oops, there we go. That's pretty much the technique that we're going to be using with lots and lots of different curves to estimate the area under a curve. Any questions about that? Let me do an example. I'm going to pick one of the simplest curves I can think of. Y equals x squared. And we're going to start at 0. And we're going to finish at 2. And we're going to estimate the area under this curve from 0 to 2. And we will use a notation. This notation is the notation that is used and very often is called the integral. So we will say this is the integral. This is how you would say it out loud. From x equals 0 to x equals 2 of the function x squared. And that is the area under. Okay. Right. I'll let you start the story. How many strips do you want to use? And remember that we're human beings. So pick a nice small number. but not ridiculously small. Like, don't say 1 strip. That wouldn't be a good idea. So give me a number of strips.
How about 4?
I like your thinking. Would you agree that 4, that's 4 strips, would be pretty easy to do here? Agreed? So what I'm going to do is I'm going to set up a table. And the reason I'm setting up a table is it's a good way of keeping track of all the numbers I need to deal with. Now, this guy starts off at 0, right? And since I'm going to have 4 strips, you can imagine there's going to be a guy here, a guy here, a guy here, and a guy here. So that guy is going to be 0.5, and that guy is going to be 1.5. So what I'm going to do is I'm going to calculate the width of a strip. Now, I think if you look at this, can you see there's 0.5? But we have a formula for doing it. So let me show you what that is. It's called B minus A over N. A is the start value and B is the end value. So in this case, it's 2 take away 0 divided by the number of strips. And so the answer you get is 0.5. Now, why is that a useful number to get? These are going to represent these points here, the x coordinates I'm going to use. So I'm going to go 0, 0.5, 1, 1.5, and finally I'm going to finish at 2. And then I'm going to find what the y values are. So imagine the height of the function at these points. Nothing squared, 0.25 squared, 1 squared, 2.25, 8, and 4. What's these guys? So that would be the height here, the height here, the height here. That's them. Now, I could use left-hand side. That would be L4. I could use right-hand side. That's going to be R4. I could do the midpoint, but if I was going to do the midpoint, I'd have to create a new table. So I'm going to just ignore the midpoint for the time being. Do you want me to do an L4 or an R4? Doesn't matter, just pick one.
L4.
Say that again, please.
L4.
Okay, let's do an L4. All right, there's my first strip. I would choose the left-hand side, which means I'm going to choose this guy here for my height. Okay. In the second one, I'm going to choose that fella. In the third one, I'm going to choose that fella. And in the fourth strip, I'm going to choose that fella. So these red rectangles are, I know that one's not much of a rectangle, but its height is 0, so it counts. I'm going to get the heights of the rectangle from these 4 numbers here. Can you see that this number here doesn't even get used when you do L4? Only the 4 on the first 4. If I turn them this way, the 4 on the left. Now, I need to find out what the area of each of these rectangles are. Well, isn't the area the width times the height? Now, the width multiplied by the height for each of the strips. Well, the width's the same number. Isn't the width 0.5? And 0.5 times the height, choose 0. The second rectangle will have a width of 0.5, and the height I'm going to use is this number. And then the next one is going to have a width of 0.5, and its height is this number. And then the last one is going to have a width of 0.5 times that number. Have you noticed that these 4 calculations are the areas of the 4 strips? You see the match? Area of the first strip, area of the second, area of the third, area of the fourth. Which is why they have calculators. This is 0. This is 0.125.
This is 0.5, and this is 1.125. And then I'll just put the whole package together. And we came out with the answer of 1.75. Oops. There we go. If you look at my very badly drawn picture, would you agree that if you added up the area of these 4 strips, these 4 red rectangles, they're actually less than the real answer? Isn't the real answer a little bit more area than that? This is called an underestimate. If we visually can see that the rectangles we are using have an area that is less than the one that were the true answer, we call that an underestimate. I don't have time, unfortunately, so you're going to have to trust me on this one. Couldn't I also do R4? Which means go back to this picture, but for each of the rectangles, couldn't I use the right-hand side, which would end up being these green ones? Great. Now, what would these green ones be? Well, I would be using these 4 guys. And I'm going to tell you the answer. Well, sort of. It's going to be 0.5 times 7.5, which is 3.75. Does anybody know how I managed to do this one a lot quicker than that one?
By factoring out the 0.5 width because they're all multiplied by the same number.
And then just adding up these guys. So do you see that when you've got these questions, you can reduce your workload by just saying, yeah, the width is 0.5 all the time. So why don't I just suck out the 0.5 and then just add the heights? You see that's much quicker, isn't it? Because you only have one addition followed by a single multiplication. Now, what would you say about this answer? An overestimate or an underestimate? What would the area of these green rectangles be? Bigger or less than overestimate? Wait a minute, just to finish here. If I know the answer is bigger than this guy, but less than that guy, don't I now have at least a boundary where the real answer lives? It lives somewhere between 1.75 and 3.75. Now, couldn't I then do 40 strips? Can you imagine as I did 40 strips, this answer would start meeting up with that answer? Wouldn't they squeeze, the answer down into, oh, you can't tell the difference? Wouldn't that be a very accurate way of being sure that the answer that your estimate is giving is darn close to reality? You see, it's quite a powerful technique, even if it is very boring and very time consuming. And that is all I have to do today. So before you go, you have to say hi.